Okay, this video we are going to see a asynchronous program in Rust. For that, we can use the libraries Tokyo and some of the features in future, and yeah, that would be enough for starting with. And the crate called request that is the crate for getting the data from some website or some API, using some API. So we can directly look into the program. This is the cargo.toml. I'm using Saturday. This is actually not required, I believe, but let it be. And a request, this if you are using the JSON or blocking features, you need to add the features, otherwise you can just ignore this if you're not using JSON. And another one, Saturday drive also is not mandatory, I think, but futures you need to add this library, and you need to add Tokyo as well, and you need to add the macros and RT core features for using Tokyo runtime and some of the Tokyo functionalities. So that is the cargo.toml, and the main is thus. So in this we are using future join all. Join all is for waiting for all the task in the Tokyo runtime. So we can use the join all. There will be, okay, if you see Tokyo, it is a runtime. It's like an infinite loop waiting for the task in the task queue. So if it will keep polling the task queue and check is there any task is ready. If it's ready, it will go and execute. And if it's again, it will poll after some time and look for any other task is ready. It will execute task 2 if it's ready. Like that, it will fully execute all the tasks, and it is executing, but you need to wait for all the tasks to complete. So that's why we are making join all. Join all will wait for all the futures. If you see, creates a future, join creates a future which represents a collection of outputs of the futures given. The return future will drive execution of all of its underlying features, collecting results into a destination in the same order as they were provided. Yeah, it will also maintain the order. And and we can just look into some of the features of Tokyo first. So the asynchronous Tokyo allows developers to write asynchronous programs in Rust programming language. Um, so that is what asynchronous we have seen. It will have an infinite loop which is looking for a task queue. If task is ready, it will go and execute. So that is the mechanism happening. And fast, that is one of the feature Tokyo is providing. And zero cost abstraction, since you are building this many abstractions in the sense you are getting a scheduler and error handling and a runtime, everything within this, just importing Tokyo and um, task queues. So there are a lot of abstractions are happening, but once it is go to the machine, it is going to be a simple binary, same as that you write manually write all this scheduler with your own code, optimized code. So that is what zero cost abstraction Tokyo is providing, since it is built on around futures. Futures also provide zero cost abstractions. So eventually Tokyo had the ability to carry through those zero cost abstraction feature. I think that is what one of the advantage of Tokyo. And it's provide concurrency. It's Tokyo provides a multi-threaded work stealing scheduler. So so what that means is, I guess if you look at Tokyo main, there is a single thread um, runtime as well as a multi-threaded runtime for Tokyo. So if you are giving Tokyo main single thread, it is going to use only single thread. But if you use Tokyo main, it is going to use multi-threaded. So if you have multiple cores in your machine, that those capabilities can be used by Tokyo if you use Tokyo main. And non-blocking IO, yeah. When hitting the network, Tokyo will use the most efficient system available to the operating system. On Linux, this means ePOL, yeah. And reliable ownership and type system. Rust ownership model and type system enables the implementing system level application without the fear of memory safety and safety. This is the biggest advantage Tokyo is getting, since it's using a Rust programming language. And I think Tokyo is providing back pressure. That means if the producer is producing more than what consumer can consume, the consumer has to put it in a queue and or make the memory run out if the consumers keep pushing uh, events or tasks to it. So that will give a back pressure to the producer. I think Tokyo is providing that feature. And there are some more, no garbage collector, modular. Okay, these are some of the features you can read through it in tokyo.rs. Having said that, we can get into this program. And as you can see, I'm using async fn main on with Tokyo main feature. That means I'm using a multi-threaded runtime, Tokyo runtime. And since I'm using since I want to pull HTML data from these two links, this is the two links, Rust language link. I'm using a request. This is a library. Um, this is a crate which gives which can you get HTML and post HTML. Those kind of things can be done through request. And one of the main advantages, it is also supporting async functionalities. um, yeah, so you can see that this request it is getting this link, and it will wait. It's an asynchronous call, and dot wait means it will make sure that this asynchronous call completes, then only it will look for call the dot text method. Then it will again wait for the completion of this dot text call. Once everything is completed only, it will send the output back to body, or it will throw back if in error, in case any error. So dot wait means it's waiting for the prior step. Yeah. So having said that, we can just get into this. Since I have too many links to pull, I am putting those in a vector um, called paths, and then I need to create task for Tokyo. So that is what I'm creating, a task vector uh, where I'm putting all the handles of those tasks. So join handles, what that means is, if you yeah, when you spawn a task, Tokyo can spawn use multiple threads for doing different threads for different tasks. So it can spawn task, and what it will return is, it will just return a join handle. uh, Join handle and on permission to join on a task. That is what join handle means. A join handle detaches the associated task when it is dropped, which means there is no longer any handle to the task and no way to join on it. Okay, that's okay. It is somewhat similar to thread join handle, but here it is an asynchronous way, and a handle for a task than for a thread. Okay, so when you are spawning task in Tokyo, when you are spawning um, asynchronous work, it will just return back a handle for the task. So this is the example in the Tokyo create document. Okay, I think we can again go back to this. So I'm just thinking that I'm going to get a lot of um, task handles, and I'm putting that in a vector called tasks. Now the next question is, I need to loop through all these links. So I'm using a for loop, and since I'm passing moving this path to the spawn, I cannot um, keep uh, I cannot keep the ownership of paths here. I have to send it down. So when I loop through each link, I make a clone and pass that to the inside to the spawn. If you're not um, passing, if you're not cloning, then there could be situations. First of all, Rust won't allow that, because Rust knows that the spawn is going to refer to the outer paths vector, which can be used by some other spawn thread task that can conflict and make a race condition. So this is definitely a step we need to do. Okay, let me see if I'm not doing this, what will happen. We can do a cargo check. This is what the problem if you are not using clone path.clone. Before earlier we were not using paths after that, but now added a new line for printing out the paths. So you can see that the error message compiler is complaining. Move occurs because path has type string which does not implement the copy trait. Value moved here. When you use the for loop, the values are actually moved. So either we need to consider borrowing here, but we don't need to borrow. So we are just trying to clone again. Still error will be there. We need to borrow. We'll borrow here. We'll see what happens. Yeah, so when you borrow here you can clone it and use, and you can use the path afterwards in some other portion of your program. Yes. Okay. um, Now we did not uh, we were here, we actually cloned the path. Now we have each link with full ownership here for this path, and we are creating a task queue for our Tokyo runtime. So that is what Tokyo.push, and we are spawning Tokyo runs, Tokyo task threads, or Tokyo task with asynchronous manner, where async we are moving all the values or environment, all the values to this block. Here what we are doing is we are getting request get for the path, for this path, and waiting for it. Once we got the result, we will check whether is it an OK response or not. If it's an OK response, we will again match the response with response text. We will call the response with text method and wait for the text result, and once that is done, this match will make sure that we got some, this wait make sure that we got some text or some result. We'll check that result whether it's OK or not. If it's OK, we will print that text and text length and path. If it's error, then it will print this error. And the first response itself was some error, then it will come here and will print this. If everything is OK, then we will return OK. That will be our OK is that will be our this handle thing. It will be a result always. That's why we are putting this OK here. And we have to close so many one curly bracket and two brackets. Since we opened them here, so you can see that this full block is running inside the Tokyo spawn, and those return handle will be pushed to task tasks queue that will be used by Tokio runtime to execute. Yeah, then we will print this paths, and we are printing out the task length. And we will wait for the join all for all the tasks, and we'll make sure that it is getting completed using this wait. Once everything is done, we will make sure that we are returning OK. Since our main has this, we have to result OK or error, so we are returning OK. Having said this, we can just try to execute this. I'm just opening a terminal. Cargo run. Yeah, we can. Okay, first let me comment out this. Yeah, both this is a vector, this is our paths. Started to task, started to task, where it is happening here. It is just executing the main thread, and it is waiting for the task. Now we are seeing response. Response, where it is coming here, response. We got text of length this many bytes from this link, that is for the path, and the second link we got this many bytes, and this is the link. Yeah, and how many tasks we are waiting? We are waiting for two tasks, two links. We are processing two links, that's why it's printing two. So that is what overall how to use a Tokio runtime and request create for getting HTML from, or JSON or anything from some APIs or web links. That's all regarding asynchronous programming uh, with Tokio. There are a lot of other way you can do asynchronous programming, but this is one of the example I have tried. So thank you all for watching this video. Bye, see you soon.